Okay, so I had a request to go over question 5B on the review, the very, very last question with the headings in it. So I wanted to do that on here. One thing I want to make sure you kind of know before I do this one, though, the problem on the quiz with the bearings in it is much, much more straightforward than this one, especially when it comes to how you have to find the angles. There's a lot less dealing with linear pairs and alternate interior angles and all that kind of fun stuff. So just keep that in mind. This one is a very challenging one. So we've got you drive through the desert on a heading or a bearing of 247 degrees from north for 15 miles. Then you turn to a heading of 25 degrees from north and drive for 17 miles. Which direction should you travel to get back to where you started? So the first part here, we've got 247 degrees from north. That is over 180. Remember from last time, we've got, going from north, like this would be 90, that would be 180, this would be 270, and then back to 360/0 at the top. So we're, somewhere closer to 270 than we are to 180. So more west than south on this one. So first thing I'm going to do, I'm going to start by just drawing a north-south line. Since I know I'm going south and west a little bit, I'm going to draw it kind of over here. So that's going to be north, that's going to be south, and that means I'm just going to say I'm starting there, and I'm going this direction with this angle being 247 degrees. And that is 15 miles. From there, I'm going to go and turn to a heading of 25 degrees from north. So this is always a good place. Draw in another north-south line, and 25 degrees from north is going to be something like this. And I'm going to do that one for 17 miles. So it should be ideally a little bit longer than this one. You don't need to draw these perfectly, but if you can get close, it does help a little bit. So that is 25 degrees there for 17 miles. And then we are interested in figuring out what direction we have to go to get back. And again, I'm going to draw in a north-south line. We're trying to eventually find that angle there. I'm going to put an X there. We've got to find other things before we can figure that X out, though. So the first thing I want to do is I want to look through this and figure out, are there any angles in here that I can find so that I actually have something to work with? I've got this side and this side. So if I knew either an angle opposite from it or the angle between it, I could do something. So first thing I'm thinking about here is, if I know this 247, can I subtract 180 and get what's left right here for me to work with? And I believe I can, if I just have a calculator sitting in front of me. So I'm going to go 247 minus 180, and that is 67. So I'm going to do my work here in orange. So 67 degrees here. That's just taking 247 minus 180. Now, what that would mean is that since these dashed lines I all drew in are they're parallel to each other, if this is 67, that would mean that this whole angle from there back to north, that's 67 as well. And since I'm doing all but the 25 degrees right there, I can do 67 minus 25 to get that this angle in here, just inside the triangle, is 42. Just this part. And now I've got enough that I can use the law of cosines to figure out what this side is. So because I've got the two sides and the angle in between. So that would look like y squared equals 17 squared plus 15 squared minus 2 times 15 times 17 times cosine of 42. So I'll type all that into my calculator. Joins the cosine of 42. And I get, when I take the square root at the other end, I get 11.6. Sorry, y, not x. So I'm going to go ahead and just erase that y and put 11.6 in. If I can figure out how to do it, if it's the previous answer in my calculator when I use it, I will use the stored value instead of that. Okay, so that helps because now I've got this opposite pair that I can use with law of sines. I also have this 15, which means I could use that to find this angle. So if I go back, I'm just going to switch the colors again. So if I want to find this angle here, the whole thing, we'll call that z for now, I can use law of sines. So I'll have sine of 42 over 11.6 equals sine of z over 15. I'll cross multiply there. And divide by 11.6. And since I'm finding the angle, now I'll do the inverse sine of all of that stuff. So I'm just going to do that. So on my calculator, I'm going to type in the inverse sine of 15 times the sine of 42 divided by, and I'm going to use the previous answer button, and it's telling me that is 59.75. I'm going to go 60 degrees for now, but if I can figure it out, I might use that answer key again. So I've got this angle is 60 degrees. And so I think I'm at a point now where I can probably figure out what x is without doing any more trigonometry at the very least. So I'm going to switch colors one more time here. We'll go with this weird like teal color. So what I could do now, since I know like this angle here is 25, that would tell me that this angle that I created is 25 as well, which means that this angle here would have to be whatever 60 minus 25 is. So 35. And then since I want x, and I've got that between that north-south line, if this is 35, I can just do 180 minus 35. And that will tell me my angle to go back. And that gives me 145. So 145 degrees, that is angle x. And I found my compass bearing to go back on. So lots and lots of stuff going on there. The hardest part of a question like this is not the trigonometry, right? Once we actually knew that was 42, finding this side, no harder than anything else we've done. Once we actually knew, then, once we had that, then using the law of sines to find this angle in the triangle, no harder than what we've already done. And then again, the hard part here is once I know that this is 60, how do I go and use just alternate interior angles, linear pairs, vertical angles, if I have them, can I use that to find the angle I want? So use those things that you've learned about way back at the beginning of the year. And I find it helpful to draw in dashed north-south lines. Since we're always measuring off of north, I know those lines are where I'm measuring my angles off of. That's where I want to start. And then I think the last thing I want to mention here is the one on your quiz, like I said, much, much simpler question. There's a lot less of this figuring out angles going around. And just as a way to kind of make sure we're really focused in on the trigonometry that we're trying to learn here, it includes a picture. So you know that at least the picture that's drawn on the paper is correct. You've just got to find basically the distance of the resultant distance and then the angle that it asks for. So a little bit less to actually worry about on the quiz. Not as crazy as something like this. This is very, very challenging. You will see stuff like this next year in Algebra 2 and pre-calc honors and things like that, but much, much more challenging than what you're going to see on this year's quiz.